Hello everyone. Today I am going to present my topic register allocation, the CPU hidden performance engine. Register allocation is an concept, uh, important concept in compiler design. It is the process of assign, assigning program variables to CPU register. Register are very small storage location inside the processor, but they are the faster memory available. The CPU can access register much faster than RAM. Because of this, keeping important data inside register can if efficiently improves performance. If variables are not measured properly, the CPU spends more time accessing slow memory. So register allocation play a major role in making software fast, efficiency, and responsive. Even though user do not see it directly, it works behind the scenes every time a program run. That is that is why register allocation is called the hidden processing engine of the. There is too many variables, too few register. Modern software program use many variables. A simple application may use dozens of variables, while large programs may use hundreds or thousands. However, CPU provides only a limited number of registers. For example, some processor may provide only 8 or 16 general purpose registers. This creates a challenge. The compiler must decide which variables are most important and should remain in register and which can be stored in memory temporarily. This is similar to having a small bag and many items. You must choose carefully which items to carry with you. Good discussions improves speeds. Poor discussions increase delays, so the compiler acts efficiently to manage this limit resource. This register is failing. Well, when all registers are already optimized, the compiler may need to move a variable out or register and store in RAM. This process is called register spelling. Later, later when the program need that variables again, it must load it back for memory. The problem is that RAM is much slower than register. Accessing the RAM may take many more CPU circles. Frequently, spellings cause performance lose because the pro- processor spends more time loading and storing data instead of doing useful computations. Therefore, the main objects of register allocation is to minimize spending and keep frequently used variables close to the CPU. And then next is different CPU architecture. Different processor have different number of registers. For example, 86 processor traditionally have few general purpose register, while architectures like MIPS or ARM may provide more register. When registers are few, the compiler face a higher pressure. It must excuse registers careful and avoids unnecessary spelling. When more registers are available, the compiler gets more frequently and can keep more variable inside the CPU. Because of this hardware, different compiler such as LVM and GCC use storage that adapt to the target processor. So register allocation is not one fixed method. It changes according to the CPU architectures. There is a graph coloring. Graph coloring once graph coloring One's classic methods of register allocation is graph coloring. In this method, variables are shown as nodes in a graph. If two variables are active the same times they are connected, the compiler assigns different registers to connect variables. This gives near optimized results, but it complex and takes more compilation time. Linear scan allocation. Another fast method is linear scan allocation. This method checks variables once by once and assign register quickly. Each register are full if spelling one's variable to memory. This method is faster than graph coloring, so it is mainly used in JIT compilers like Java, Android ATR, and LLVM faster mode. Next one is track-based allocation. Track-based allocation divides the program into small execution paths called tracks. Four importance are frequently used tracks. The compiler use advanced methods like graph coloring. For less important track is use fast methods like linear scans. This gives a balance between compiler speed and runtime performance. And next one, key components of registers. Next one, key components of registers. There are four major components involved in register allocation. Concealings, spellings, live range, assignments. Concealing remove unnecessary move in some intersections by assign relates variable to the same registers. Spellings move less important variable to memory when registers are full. Live range divide long variable use into smaller integrates of easier allocation. Assignment final mapping of virtual registration to actual hardware registration. Together, these techniques reduce incidence concepts, improve sprints, and use resourcing enhance. And next, this one is real world benefits. Real world benefits efficiently. Register allocation provides major real world benefits. Studies show that good allocations can genuinely improve benchmark performance and reduce memory traffic. In invention system, limited hardware resource required careful register usage. In high performance computing, faster executions is important to scientific calculations. And every gaming system are real time application benefits because every milliseconds matters. So these compilers these compilers optimize directly affects everyday technology. The future the future is smarter faster allocation. Register allocation is still an active research area. Future improvements includes lightweight algorithms that run faster, smarter spelling discussions, and integrated optimization techniques. So system also use proprietary data to understand to which code run most often than optimize accordingly. In the future, artificial intelligence may help compiles make every better allocation discussions automatically. This means software can become faster without charging original programs. These are the so, thank you. Thank you everyone.